Okay, we already observed when you have a function that you have one element of the domain, the independent variables goes to one element of the range that are the dependent variables. You know, this is highly used in many ways. This is highly used in many subjects. But today we're going to use it not with graphs. We're going to get domain and range not with graphs, but we're going to find it by using algebraic expression. So this is what we're going to do. This is what we're going to start, and we're going to see it by first starting with the notation. So this is the notation of a function. So this is when you call function of x. Okay, when you have a function of x, this is the notation we use. Now, this doesn't mean that you're multiplying f times x. It means that f is a function of x. That if you put a value of x here, it's gonna lead you to an answer of this function. So let's start with a simple one. Let's say that you have the function fx equals x to the third power minus 2x plus 1. Okay, so what means this? It means that, for example, if I choose x equals 1, I'm going to replace all the values of x here by 1. So let's say that you have x is 1, so I'm going to use 1 to the third power minus 2 times 1 plus 1. No, this third power is, it's like different. Okay, now, so I just need to operate. So 1 minus 2 is negative 1 plus 1 is 0. So observe that for when x is 1, this function is going to give you 0. It's going to lead you to 0. Now, how to get the domain of a polynomial function? Just try to identify what are the possible values of x that you cannot use here to get a real answer in fx. In this case, as you can see, you have all possible values of x because I can use any value of x here and it's going to lead me to a real answer here. So this is why I'm going to tell that the domain is just all real numbers. This is the way to notate all real numbers, or we can notate it using a set form in which we set that x it's defined by the x that belongs to real numbers. And this is how you can get the domain of the polynomial function. The domain of all polynomial functions is going to be all real numbers because I can use any number, raise it to any power, and it's going to give me any answer. Now, to get the range of polynomial functions, we have some deal. If the degree of the polynomial function is odd, like in this case, we can say that the range is all real numbers. Now you may ask why? Because if I raise this number to any power, it's gonna give me a higher number, right? But if you use a negative number, it's gonna give me a negative number. So if I use negative infinite, it's gonna give me negative infinite here. Negative 10 to the third power is gonna give me negative 1000, so it's going to be negative. If I use positive numbers, they're gonna give me positive numbers. So it means that the range is all real numbers as well. So I'm going to use y such as y belongs to real. This is our first type of functions. The first type of functions in the polynomial functions we have that all real numbers applies when it's an odd number for range and domain. However, if it's even, like x squared, we cannot say that. We need to use the graph, or we need to use another strategies that I'm not going to discuss in this video. Now, let's see what happened with other type of functions, like rational functions. Rational functions. Rational functions are functions that in which you have, let's say, like a subfunction, or we have a structure in which we have a division between two polynomials to show our answer. In this case, we have two options, like 1 over x squared plus 3x plus 2 and 1 over x minus 1. Now, I want you to think, what are the possible values of x that I cannot use in these rational functions? When I cannot use, or what is the value of x I cannot use in this function? I suggest you to start with this one first and try to think. What would be a possible value of x that I cannot use here? Now, if you think a little bit, you understand that I cannot have denominator as 0. In rational functions, denominators cannot be 0. Okay? So this is our constraint. We cannot use in our domain any number that gets in the denominator 0. For example, here, I cannot allow x minus 1 different than 0. So it means that x should be different than 1. Okay? So our domain is going to be told by x in a way that x is different than 1. Obviously, x belongs to real numbers. Okay? X belongs to real numbers, x different than 1. Okay, it's better to write it first, that x is a real number and that x is different than 1. You know? X belongs to real and x different than 1. So in this way we have that for our rational functions, denominator different than 0, in this case, if the function is 1 over x minus 1, so x cannot be 1. This is the domain of our function. In this case, x squared plus 3x plus 2, so we have to write x squared plus 3x plus 2 different than 0. So in this case, we have a situation that we have a polynomial, so we can factor the polynomial x plus 2, two numbers whose product is 2 and whose sum is 3 will be x plus 2, x plus 1 different than 0. And we can use something called the zero factor property, in which these two cannot be 0, so it means that x cannot be negative 2 and x should be different than 1. So our domain is going to be x defined as x belongs to real, but x is different than negative 2 and different than negative 1. And this is how you get the domain of rational functions. When you have a rational function, you just need to identify when the denominator is 0, and these are the values that are not allowed in your domain because you cannot have. In some cases, this is what we call an asymptote. It would be an asymptote in some cases, but it's something we will see later, not now. And finally, there's another type of functions that are very interested, that are calling the radical functions. So the radical functions could be functions of the form, let's say, f of x equals a square root of 3x minus 1. Now I want that you wonder, before I continue, what will be the option that we need to put here in our function to calculate the domain. What are the possible values of x that are not allowed? What are the values of x that are not allowed? Now, if you remember, I cannot calculate or I cannot have real values of negative roots. So it means that the argument, that is the term that is inside the square root, the argument should be greater than or equal to 0. So it means that to get the domain, I should put 3x minus 1 greater than or equal to 0. So it means that if I add by 1 and divide by 3, I get that x should be greater than or equal to 1/3. And this is how do you get the domain. Okay, this 3 is funny. Okay, so now I can write the domain as x in a way that x belongs to real and x greater than or equal to 3. Oh my god, I'm doing this 3 is funny. And finally, or you can write it in the form of set or in interval form, so it will be from 3 to infinite. Oh, it's not 3, it's 1/3. Okay, 1/3 to infinite. And this is how you get for radical functions. Now, just remember to sum up, if you have these 3 types of functions, if you have polynomial functions, the domain is going to be all real numbers. If you have rational functions, if you have rational functions, the domain is when, or the numbers that are not allowed in the domain are those for which the denominator is 0. So denominator should be different than 0 to get the domain. And finally, for radical functions, we just need to take into account that the root, if it's a square root or any even root, we need to take into account that the domain is going to be all the values in which the argument, the term inside the root, is greater than or equals to 0. So I hope that with this video you understand how to get domain and range, in some cases, from this expression. Maybe you ask why I didn't get the range from rational and radical functions, because in this case we need to use another idea that we're going to see later. Okay, so I hope that you understand this video, that it helps you a lot, and see you soon. Bye bye.